In MCQ number 4, we are tasked to draw out the following dot and cross diagram for barium peroxide. Now, some important clue here is that the two oxygen atoms are initially joined by a single covalent bond. And in this case here, the dot represents the electrons that came from oxygen. The dot represents the electron that came from your oxygen, whereas the cross represents the electron that came from your barium. So, in any way, ordinary diatomic oxygen, we should be looking at O double bond O, indicating that they are actually sharing a total of 2 pairs of electrons. However, in this case, as per what the question wanted, we are just looking at O single bond O. Now, this must have meant that originally each of the oxygen did not have 6 valence electrons, but only 7 valence electrons, indicating that they only need 1 more electrons to become stable. They must have accepted electrons from a cation. In this case here, the cation that is donating the electrons, in this case, it will be our barium, which is represented with a cross itself. So normal oxygen again, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and 6. And the extra electrons that was donated from your barium. This will show that each of the oxygen has 7 valence electrons, as opposed to the original elemental oxygen whereby each actually has 6 valence electrons. And in this case here, the interaction between these 7 valence electron oxygen will not be a double bond, but rather be a single bond. And as such, this is representative of only sharing just a single pair of electrons represented with just a single covalent bond. So from here, we know that the overall charge of this anionic oxygen, which is an O2, must have come on as a 2- because it has actually accepted 2 electrons from your barium 2+. So just looking at the top right, you see that there's a 2- in option C and a 2- in option B. Now, barium definitely should be losing 2 electrons to give you a charge of 2+, since barium is from the group number 2. It will lose 2 of its valence electrons. I have another 2+ over here. And just to do a final stock take in terms of the additional electrons that came from your barium, you see one in one of these oxygen here, you see another one in that of this oxygen over here, and this is the reason why they only share a single pair of electrons rather than 2 pairs of electrons. In this case here, the correct answer for this question will be option C.